Okay, the last part of our review of all things linear is arithmetic sequences. So recall that a sequence is just an ordered list and it will have a pattern of how you get from term to term. Let me get my pen. So we will study two different sequences this course, but the first one is going to be arithmetic, and it is a linear function because there is a constant rate of change. But with a sequence, an arithmetic sequence, we don't call it a constant rate of change, and we don't use the variable m for slope. We call it the common difference. So you can see from 3 to 5, we are increasing by 2. Oops. So from 3 to 5, we add 2, 5 to 7, we're adding 2, 7 to 9, we're adding 2, 9 to 11 is plus 2. So this 2 is our common difference. It is like slope if we were talking about a linear function. Now, notation of a sequence. The variable n is used for the input instead of x, and the variable a sub n is used for the output values instead of y or f of x. So when you see n, you need to know that that is your input value, and a sub n, that is your output value. So let's put these into a function table. So first of all, let's talk about the domain. So the domain of all sequences is going to be 1, 2, 3 because they represent the position of each term. So here's our sequence. So 3 is our first term, 5 is our second term, 7 is our third, 9 is the fourth term, 11 is the fifth term, and so on. So if we were going to write this sequence as a function, our x's are 1, 2, 3, 4, 5. But remember, we're not using x for arithmetic sequence, we're using n. So n is 1, then 2, 3, 4, 5, and so on. Now it says the range of all the sequences is each element or each term of the sequence. So the sequence terms themselves are the output. But instead of f of x or y, we use a sub n. So here are the outputs. So we could write the notation. So if we said a sub 1 equals 3, a sub 2 equals 5, a sub 3 equals 7, and we could go on and on. We can also look at this as 1, 3, 2, 5, 3, 7. And if we were to graph our sequence, so we have 1, 3 and 2, 5 and 3, 7, we can see that we have a scatter plot. And remember, we do not connect the dots of a scatter plot, and a sequence is a scatter plot because there are no values in between. It is just a specific set of numbers that stand alone. Now let's look at the recursive form and the explicit form. So the recursive form just defines your sequence. And so to define a sequence, you have to tell your reader the first term and the pattern, the common difference. So if I ask you to write this in recursive form, you're going to say a sub 1 equals, tell the reader where to start, and then you need to tell the reader how to get to the next term. Well, it's plus 2. So we put plus 2. So it's just a fill in the blank. All this other notation, so this part and all of this, that is the same every time. You're just filling in the first term and the common difference, the pattern. Now, explicit form is actually the formula in which we can identify any specific term we want in the sequence. So this is going to look like slope-intercept form. So again, we're just going to fill in the first term plus our common difference, and then it's always n minus 1. Now, you may be asked to identify explicit form as you see here, or it may be simplified, which is the way I prefer. So we are going to distribute, and then we're going to combine like terms. So now it looks like y equals mx plus b. So we could find any term that we wanted. So let me go back. So let's just say we wanted the 50th term of this sequence. We simply say the 50th term is when n is 50. We're going to multiply by 2 and add 1. So that's going to be 101. So the 50th term is 101. We could write this as an ordered pair, 50, 101. Okay, now given the recursive form, we're going to write the first 5 terms in the explicit form, and we're going to find the 50th term here. So here I have a sub 1 equals 8, a sub n equals a sub n minus 1 plus 3. So we are going to start with 8, and our pattern is plus 3. So 8 plus 3 is 11, plus 3 is 14, plus 3 is 17, plus 3 is 20, and so forth. The explicit distribute, combine. We want the 50th term. Plug 50 in for n because that's the position variable. So the 50th term, that will be 150 plus 5, 155. We could write that as 50, 155. Okay, now we have 2 terms, and we are going to write the explicit form and the first 5 terms and the 50th. So we're going to write a system. So we are going to use the explicit form to write our system. So we're going to say negative 11 equals, we do not know the first term, we do not know the pattern, the common difference, but we do know that negative 11 is the 4th number of this sequence. The next one is the term is negative 26. We don't know the first term, we don't know the pattern, but we do know negative 26 is the 9th number in the list. Now let's simplify each of these. 4 minus 1 is 3. 3 times d is 3d. 9 minus 1 is 8. 8 times d is 8d. So now we have these 2 equations, and we can use elimination. I am going to eliminate the a sub 1's every time simply by multiplying one of the equations by negative 1. This gives me positive 11, negative a sub 1, minus 3d. This gives us negative our a sub 1's are eliminated, divide by 5, and d is negative 3. So our common difference is negative 3. Now to find our first term, I'm going to take just this original and I'm going to plug in negative 3 for d to find my first term. 3 times negative 3 is negative 9. Isolate a sub 1, add 9 to both sides, and the first term was 2. So we have negative 2. We were going down by 3, so that will be negative 5, negative 8, negative 11, negative 14. Explicit form, our first term was negative 2, and our common difference was negative 3 times n minus 1. Distribute and combine. I want to know the 50th or whatever term you want to find. And we get negative 149. So we could write that as 50, negative 149. So that is applying the elimination method to arithmetic sequences. Write the explicit form to find the domain and range. Jude begins with $40 he received from his grandparents. He will continue saving $20 each week to buy his own Xbox. Determine how many weeks it would take him to buy the Xbox. That is $400. So we have weeks that he's saving and we have total money that he is saving. So the domain, which is always going to be 1, 2, 3, 4, is going to be weeks. So 1 week, 2 weeks, 3 weeks, until we don't know how many weeks. That's what we're going to answer. So the range, the output, the sequence is going to be total savings. So here's where we have to stop and pause. Okay. In week 1, so he starts with 40 and he continues to save 20 each week. So he's not started saving with the $40. So he has 40 right up front. And after the first week, he has $20 more. So in week 1, he has $60. Then in week 2, he's going to have 80. And then he's going to have 100, all the way until he reaches 400. So now we need to write our explicit form. So A sub n equals our first term is 60 plus 20 times n minus 1. Distribute and combine. So we want 400. So we're going to plug in 400 for the output, and we're going to find what week n is going to be before he has enough money. And then we have 360 divided by 20, 20n divided by 20. This is going to be 18. So in 18 weeks, he will have $400. Now let's take a look at our last problem. There are 60 candy canes on the first row of Miss Thomas's Christmas tree. Each consecutive row going up the tree has 5 less than the previous row. The top row has 5 candy canes. How many rows of each candy canes are there? So there are 60 candy canes on the first row. So we're talking about rows because we have row 1, row 2, row 3, and then we have candy canes. Now, on row 1, there are 60. So we are given the very first element of our range. We didn't have to add anything to it. Then it said that each consecutive row, so the next row up is going to be 5 less. And it says the top of the row has 5. So we're going to get all the way down to there when there are 5 candy canes. So we need to know how many rows. So let's write our explicit form. We started out with 60, and then it went down by 5. Distribute and combine. Let's go over here. We want to know when there are 5 candy canes. So that's the output. So we put it in the Y spot, the output side. We're going to subtract 65 from both sides. And the number of rows is 12. And there you go. I hope this helps.